Good day, everyone.
Good day.
We are Group 4, and today we will do a discussions on the topic bioengineering versus technology engineering, where IDHAM and ZAFRY will talk about bioengineering, while me and Angeline will talk about technology engineering. So throughout this discussion, we will each present our points, and you may interrupt if you have something to say with a suitable point at time. So let's begin with Adam.
Okay, thank you, FATIHah. For my opinion, I believe pure electronics offer more deeper, more strong fundamental for understanding electronics. It focuses on theory, mathematical principle, and the behavior of electronic components like transistor, capacitor, and transistors. These are crucial for innovation. For me, top universities like UTM and UM emphasize theory in their engineering programs. Their graduates are now leader in automotive, in energy, and test industries. And then big companies like Petronas and Sinderby recruit engineers specifically for their strong grasp of fundamental concepts.
I see your point, Adam, but I believe applications and adaptability are just as important in the industry today. What can you have to say about it?
Okay, FATIHah, I want to say when you study pure electronics, you don't just fit or use technology. You design a system from scratch, which is essential in R&D. Plus, with strong fundamental industry programs, engineering graduates become future innovators, but don't just technicians. So I want to conclude, pure electronics is the root of all breakthroughs. Without it, technology would not evolve. So that's all. I pass to ZAFRY.
To add on, based on my point of view, pure electronics is like learning the grammar of language, which is you need to understand how every piece works before you can write the masterpiece. In pure electronics, we study about processing signal, complex circuit design, and complex calculations. These skills are not easily to understand by practical shortcuts.
But ZAFRY, do you think that apply those parts practically is more important in nowadays fast-moving industry?
Yes, practical skills are important, but without deep theoretical knowledge, we might end up using technology blindly because without knowing how it works and why it works.
That's true. But in my real world job, they just need to make it work, not explain the theory.
They might be in the case in some roles, but to lead innovation and develop smarter, more efficient systems, pure theory is vital. It's what enables us to go beyond what already exists. To wrap up, mastering fundamentally gives you control, power, and insight to shape the future.
Okay, for me, I fully respect those points from pure engineering, but I'm a firm believer in engineering technologies. This field bridges theory and practicals. It's designed to meet industrial needs directly and efficiently. Many jobs today require people who can operate, troubleshoot, and maintain systems, not just design them. This where technology-based program shines.
But can they innovate if they don't fully understand the theory behind the system? Because I think innovation isn't limited to theory. Sometimes the best innovations come from solving real problems and through hands-on experience.
True, but you can refer back like UTM and Canada's college. You can become a certified technologist in just 3 or 3.5 years. It's quicker, cheaper, and in the section like oil and gas or manufacturing, technologies earn salary comparable to engineers.
Okay, then, but do you think short duration provide enough depth and exposure?
Perhaps not for deep R&D roles, but for operation excellence and applied innovative is enough. It's perfect. In addition, engineering technologies is open for door for many roles. Like the roles is more flexible in design, support, operations, maintain QA, or anything that related to the manufacturing. Plus, it's easy to move on to the business or entrepreneurships since you are already ground in the practical realities. So, in conclusions, engineering technologies produce job-ready professionals who can handle industry challenge immediately.
I agree with Andrews. Electronic is more relevant in a world that constantly changing like the one we're living right now. It's interdisciplinary mixing between AI, IoT, robotics, and even sustainability.
But do you think without strong fundamentals, innovation might suffer?
I disagree. While fundamental matters, the world doesn't wait for perfections. It rewards those who can make it happen and provide a working solution now. In technology engineering, we learn to apply knowledge in a flexible ways. We build smart infrastructure, manage a data system, and also optimize an energy use.
But I have one question. What about solving complex failure or system design issue?
That's where the collaboration happens. Engineers and technologists work together, and not everyone in a project have to solve some equations some of them just there to make it function efficiently. The technology program focus on base learning, teamwork, and adaptability. They equip us to work across department and also industry. To summarize, engineering technology train us for the now and the next. It's faster, practical, and also aligned with current global needs. So thank you everyone. That was a good discussion that we are having. So from today's discussion, that it's clear that both of you point out the benefit of the pure engineering, provide the foundational knowledge essential for innovations and system creations. And our point also in technology, we aim to technology electronic offer immediate applicability, speed, and practical skills suited for the modern industry demands. So both pathways are valuable and necessary. They support different aspects of technology's progress and should be seen as complementary. So you guys agree with me?
Yes.
So I guess this
Ethically, yes.
yeah. So yeah, I think this is where we end our discussion. It's a good discussion we are having. So I hope we can sit again and talk about this in more detail later.
Okay, thank you.
Thank you, everyone.